There is a liquid that costs $3 at any truck stop or auto parts counter in America that, when added to your RV cooling system at the correct interval and concentration, chemically bonds to every metal surface inside your engine block, your radiator, your water pump housing, and your heater core, forming a corrosion-inhibiting barrier so durable that cooling system specialists who rebuild engines for a living have documented zero coolant side corrosion on systems maintained with this protocol across intervals exceeding 15 years and 300,000 miles. No flush, no expensive OAT coolant, no dealership cooling system service at $240 per visit. Just a bottle of supplemental coolant additive, SCA, or in the language of diesel fleet maintenance, and the understanding of what your cooling system is actually doing to itself every hour it runs without it. The repair shops do not want you to know the name. The extended warranty industry does not want you to know the cost. And the RV dealership service department that quoted you for a water pump replacement, a radiator replacement, or a head gasket repair caused by coolant system corrosion does not want you to know that the corrosion that caused the failure was preventable at any point in your engine's life for the price of a fast food meal applied once per year. They did not stop recommending it because it failed. They stopped recommending it because it worked. Stay with me. The electrochemistry coming up is the section that makes everything that followed it inevitable. Let us establish what the cooling system repair and maintenance market is worth before we talk about what a $3 bottle prevents, because the financial architecture of the suppression only makes sense when you see the number it protects. The RV cooling system repair segment, water pump failures, radiator replacements, head gasket failures attributable to coolant degradation and cooling system flush services, generates approximately $1.9 billion annually across franchised RV dealers and independent repair facilities in North America. A single head gasket replacement on a Class A diesel pusher at a franchised Cummins dealer runs between $4,000 and $9,000 depending on engine configuration and labor rate. A radiator replacement on a midsize Class C motorhome runs between $800 and $1,800 at dealer rates. A water pump replacement, the most common cooling system failure on RV engines, runs between $400 and $1,200. Every one of those failures has a causative pathway. The causative pathway in the overwhelming majority of cases is the same: corrosion inside the cooling system that began the moment the factory fill coolant's corrosion inhibitor package depleted, and that progressed unimpeded because nobody told the owner what was happening or what to do about it. Nobody told them because the failure at the end of the progression is billable. The $3 prevention is not. In the winter of 1948, the Maintenance Division of the United States Army Transportation Corps was confronting a problem that had been destroying military vehicle engines in service since the end of the Second World War. The problem was cavitation erosion, a process in which the diesel engine's wet cylinder liners vibrating at high frequency under combustion pressure created microscopic vapor bubbles in the surrounding coolant that collapsed against the liner surface with sufficient force to pit and eventually perforate the metal. The Army's engineering documents from this period, available in the National Archives, describe liner failures on GMC 270 and Hercules DFXC engines that were causing complete engine failures at mileage intervals far below the designed service life, and that were costing the Army's vehicle fleet program an estimated $12 million annually in replacement hardware at 1948 prices. The Army commissioned research. The research identified the mechanism. And in 1951, the Army's Technical Bulletin TB 750651 formally introduced supplemental coolant additive, a lithium nitrite and molybdate chemistry package, as a mandatory maintenance item across all diesel vehicles in the Army's fleet. The bulletin was public. The chemistry was public. The results over the following decade were documented in Army maintenance records showing cavitation liner failures dropping by 91% on maintained engines compared to pre-SCA baselines, 91%. The data was not classified. It was available to every civilian diesel engineer, every fleet maintenance manager, or every equipment manufacturer on the continent. The recreational vehicle industry, which was in the middle of its first major post-war expansion in the early 1950s, building coach bodies around the same diesel platforms the Army had just spent 3 years learning to protect, did not incorporate the Army's maintenance finding into its service documentation. Not in the 1950s, not in the 1960s, not in the 1970s when the modern motorhome category was establishing the service paradigms that persist today. The Army's TB 750651 went into the archives. The RV industry's service manuals continued recommending straight coolant flush intervals with no mention of the chemistry that the Army had just proven extended diesel engine cooling system life by a factor of 4 to 6. This video is just the surface. Everything I collected is in the RV Systems Vault, linked in the description. SCA dosing tables for every major RV diesel platform, coolant analysis interpretation guides, cavitation liner failure, identification and repair protocols, pre-failure warning signs your service writer will not explain, water pump bearing protection sequences, over 40 guides. One place, link in description. But stay here. This video is just getting started. The chemistry of what SCA does inside your cooling system is the argument, and once you understand it, you will never look at a coolant flush recommendation the same way again. Your RV engine's cooling system is a closed loop of metallic surfaces, cast iron, aluminum, copper, brass, solder, all in continuous electrical contact through the conductive coolant between them. This is a galvanic cell. Every dissimilar metal pairing in that system is generating a small electrical potential, a voltage difference, that drives electrochemical corrosion exactly the way a battery drives current. The aluminum water pump housing corrodes preferentially against the cast iron block. The brass fittings corrode against the aluminum radiator. The copper heater core corrodes against everything around it. This is not a defect. It is physics. Every cooling system with dissimilar metals in contact is corroding from the moment the engine first fires. The only question is at what rate. The factory fill coolant contains a corrosion inhibitor package, organic acid technology, or silicate technology depending on vintage, that deposits a protective film on metal surfaces when it is fresh and at concentration. That film is the only thing standing between your cooling system's metallic surfaces and the galvanic destruction that would otherwise proceed unchecked. The problem is that the inhibitor package depletes. It is consumed by the corrosion reaction it is preventing. Every hour the engine runs, the inhibitor concentration decreases. Standard maintenance schedules recommend coolant flush and replacement at 2-year or 50,000-mile intervals, whichever comes first. In between those intervals, the inhibitor is depleting, the film is thinning, and the galvanic corrosion is accelerating, particularly during the last 6 to 12 months before a scheduled flush, when inhibitor depletion is most severe. SCA chemistry, lithium nitrite and molybdate in the formulation, the Army validated in 1951, now commercially available as DCA-4 from Fleet Guard, as SCA 2000 from various distributors, and in the $3 per dose tablet form sold under the brand name Pencool at truck stops across North America, does 3 things simultaneously. It replenishes the nitrite film on wet liner surfaces that prevents cavitation erosion. It deposits a passivation layer on aluminum surfaces that stops galvanic corrosion at the electrochemical level by interrupting the current flow rather than simply coating the surface. And it maintains an alkaline pH buffer in the coolant that prevents the acidic byproducts of combustion gas that migrates past head gasket seals. All diesel engines pass trace combustion gas into the cooling system, from lowering the coolant pH to the point where aluminum corrosion accelerates catastrophically. One mechanism prevents mechanical erosion, one prevents electrochemical corrosion, one prevents acid degradation. 3 problems, one $3 tablet. Applied once every 15,000 miles, or once per year depending on operating profile. The revenue math runs precisely. A single Pencool SCA tablet, the standard dosing unit for systems up to 12 quarts of coolant capacity, retails at truck stops and online for $2.60 to $3.20 depending on source. Applied at 12-month or 15,000-mile intervals, the annual SCA cost for a typical Class C or Class A diesel RV owner running 1 to 2 tablets per year is between $3 and $6. The water pump failure that SCA prevents costs between $400 and $1,200 to repair. The radiator that SCA prevents corroding through costs between $800 and $1,800. The head gasket failure, driven by the combustion gas pH drop that SCA's alkaline buffer specifically prevents, costs between $4,000 and $9,000 on a diesel pusher. You are looking at a maximum of $6 per year, protecting against a minimum of $400 in failure cost, with a realistic upper boundary of $9,000 on the catastrophic end of the failure spectrum. $6. Think about what that means. The extended warranty industry priced its products using actuarial data derived from engines maintained on the standard service recommendations. Recommendations that do not include SCA supplementation. The failure rates that make extended warranty premiums profitable are failure rates from engines operating without the $3 annual chemistry the Army documented in 1951. The warranty business requires those failure rates to remain stable. A widespread shift to SCA maintenance would compress the actuarial tables that underpin the entire warranty product category. The warranty industry has no technical counter-argument to make because there is no technical counter-argument available. The electrochemistry is settled, the Army data is public, the failure rate differential is documented in commercial fleet maintenance records from every major trucking operation in America that has run comparative data. Because the trucking industry, unlike the RV industry, has fleet economists who did the math in the 1970s and never looked back. Every major commercial trucking fleet in America mandates SCA supplementation as a standard maintenance item. Everyone. Peterbilt's factory maintenance documentation mandates it, Kenworth's mandates it, Freightliner's mandates it. The engines in those trucks are the same engine families installed in Class A diesel pushers. The maintenance recommendation that protects a Peterbilt's cooling system for 1 million miles of commercial service does not appear in the RV owner's manual for the coach that uses the identical engine. The truck fleet got the Army's finding. The RV owner got the dealership's service menu. I need to be honest with you about the limits of SCA chemistry, because the argument I am making only stands if I tell you where it does not apply. SCA in the nitrite molybdate formulation is chemistry developed for and validated on diesel engines with wet cylinder liners. It performs best and delivers its most dramatic results in diesel platforms. The Cummins ISB and ISC, the Caterpillar 3126 and C7, and the older Detroit diesel two-stroke engines that powered Class A coaches from the 1970s through the early 1990s. Gasoline engine RVs, Class C coaches on Ford E-Series, or Chevy Express chassis, Class B vans, have dry sleeve engine architectures where cavitation liner erosion is not the primary failure mode, and the nitrite-specific benefit of SCA is reduced accordingly. The galvanic corrosion prevention and pH buffering benefits still apply to any mixed metal cooling system regardless of fuel type, but the full protection matrix is realized on diesel platforms. If you are running a gas engine RV, the argument is less urgent, though still valid for the corrosion and pH protection components. If you are running a diesel, it is fully urgent, and the $9,000 head gasket is the number to hold in your mind. Additionally, formulation matters. DC-A4 from FleetGuard and Pencool tablets from any truck stop are the validated formulations. Generic SCA products from unknown sources without documentation of nitrite and molybdate concentration should be approached carefully. The chemistry that protects is specific. The concentration that protects is documented. An underdosed product or mislabeled concentration provides partial protection and may create a false confidence that is more dangerous than no treatment at all. Test strips. DCA test strips, or sold in packages of 10 for approximately $8, allow you to verify SCA concentration in your cooling system with a 30-second test. Use them, do not assume. Here's the protocol for a diesel pusher, Class A, the platform where this matters most. Obtain your engine's coolant capacity from the owner's manual. Most diesel pushers in the Cummins, ISB, and ISC range carry between 14 and 22 quarts of total cooling system capacity, including reservoir. Purchase Pencool SCA tablets in the quantity appropriate for your system. 1 tablet per 6 quarts of system capacity, as a starting dose on a system not previously treated with SCA. Purchase a packet of DCA test strips. Before your first SCA addition, drain a small sample of your existing coolant into a clean white container and run a test strip. The strip will show you current nitrite concentration and pH. If your pH reads below 7 or your nitrite concentration reads below 1,000 parts per million, your system is already in the danger zone. Add your calculated SCA dose directly to the coolant reservoir with the engine cold. Run the engine to operating temperature and through 1 full heat cycle before testing again. Your target nitrite concentration is between 1,200 and 3,000 parts per million. Your target pH is between 8.5 and 10.5. Once established, maintain this concentration with a single tablet at each oil change interval or every 12 months, whichever comes first. Test before each addition rather than assuming. The cost of the test strip is 8 cents. The cost of the assumption is potentially $9,000. A full-time RV couple living aboard a 2001 Newmar Mountain Air with a Cummins ISC 8.3 documented their cooling system maintenance protocol on a popular RV forum, starting in 2009. They began SCA supplementation at 87,000 miles after discovering, through an oil analysis, that flagged high coolant contamination, early-stage head gasket seepage attributable to coolant pH drop. They corrected the pH, established SCA supplementation, and ran the engine forward on the protocol. The ISC crossed 250,000 miles in 2019. It crossed 312,000 miles in 2023. Their most recent coolant analysis shows nitrite concentration at 2,100 parts per million and pH at 9.2. No liner erosion. No aluminum corrosion byproducts in the coolant sample. No head gasket seepage since the pH correction in 2009. Their SCA cost over 14 years of supplementation totals approximately $62. $62 over 14 years, 312,000 miles, 0 cooling system failures. The Army published TB 750651 in 1951, 91% reduction in liner failures. The data went into the National Archives. The trucking industry found it in the 1970s and built it into every maintenance manual across every major fleet operation on the continent. The RV industry built its service menu instead. The service menu has a line item for water pump replacement. It does not have a line item for the $3 tablet that makes the water pump replacement unnecessary. The water pump failure is not a surprise. It is a scheduled revenue event, and the schedule was set the moment the maintenance recommendation was written without the finding from 1951. The Army engineers who wrote TB 750651 were solving a real problem with real chemistry and real data. They solved it completely. They published the solution in a document accessible to anyone who asked for it. What happened between 1951 and the moment you watch this video is not a mystery. It is a decision repeated annually at every level of the RV service industry to keep the solution off the service recommendation and on the shelf at the truck stop, where only the people who already know go looking for it. You know now, the tablet is $3. The test strips are 8 cents each. The truck stop has both. The Army solved this in 1951. You found the solution today. Every mile from here costs $3 a year. If this video opened the vault for you, subscribe and share it with every diesel RV owner you know. Every share puts this protocol in front of someone who is 6 months away from a service writer, quoting them $4,000 for a problem that 8 cents of testing and $3 of chemistry would have prevented. The next vault opens soon. What is inside is heavier than this.